In this video, we're going to take a look at section 1.2, which is on formulas and applications. Now, our first objective is we're going to be evaluating formulas and solve a formula for a specified letter. Now, the definition of a formula is it's an equation that represents or models a relationship between two or more quantities, meaning you'll have two or more variables in the equation. Let's take a look at an example. Body mass index I can be used to determine a healthy weight. An index in the range of 18.5 to 24.9 indicates a normal weight. Body mass index is given by the formula I is equal to 703 W divided by H squared, where W is the weight in pounds and H is height in inches. So Roland is 6 feet 1 inch tall and weighs 195 pounds. What is his body mass index? Okay. So first, let's take a look at the information that's given to us. Okay, we're given how tall Roland is, so we're given the height. And then we're given his weight is 195 pounds. Now, one thing to be careful with is the height has to be in inches. Now, the height that's given to us is in feet and inches. So we have to convert that into straight inches. Okay. So 1 foot is equal to 12 inches. So if Roland is 6 feet 1 inch tall, okay, our height in inches will be, so 6 times 12, that'll put us at 72 inches. And then we have that 1 extra inch, so he is 73 inches. We were also given his weight. We were given W, which is 195 pounds. Okay. And now we have the information that we need to find his body mass index. We'll just plug it into our formula. So we have I is equal to, we have 703 times W. Well, our W here is 195 pounds. So we have 195. Then we have divided by H squared. So his height is 73, so we're going to have 73 raised to the second power. Now let's go ahead and simplify. So I'm going to go ahead and multiply the numbers in the numerator first. So we have 703 times 195. This gives us 137,085. 137,085. And we have divided by, okay, our height squared, so we have 73 raised to the second power, which gives us 5,329. And now we're going to go ahead and divide. So we have 137.85 divided by 53.29. This is going to give us 25.7. Okay. So Roland's body index is 25.7. Now, a follow-up question would be, does his body mass index, is it in the normal weight? So it says normal weight is 18.5 to 24.9. Now, Roland is 25.7 body mass index. So this is over the range, which indicates it's not a normal weight. Let's take a look at another one. So it says Keisha has a body mass index of 24.5 and a height of 5 feet 8 inches. What is her weight? Okay, so this time we're given different information. We're given her body mass index and we're also given her height. This time we want to figure out what her weight is. Okay. So let's go ahead and write out the formula for body mass index. We had I is equal to 703 times W all over H squared. Okay, so this time we're given I. So I is equal to 24.5. And then we're given height. Remember, height, we have to convert it into just inches. So first, 5 feet. 5 times 12 corresponds to 60. So the 5 feet is 60 inches. Plus that 8. You get 68 inches. Now let's go ahead and plug in our information. So our I is 24.5. So we have 24.5 is equal to 703. W is the variable we're trying to solve for. We have all over h squared. So we have 68 raised to the second power. Now let's begin to simplify. So we have 24.5 is equal to 703W divided by, and now the 68 raised to the second power. That gives us 4624. Okay, now remember, keep in mind I'm trying to solve for W here. So if I wanted to solve for W, first thing I could do is get rid of the fraction. So I can multiply by the denominator. So I have 4624 times 24.5 is equal to 4624 times 703W over 4624. Let me make this a bigger dot to indicate its multiplication. Okay, so now we're left with, okay, so 4624 times 24.5, that gives us 113,288. We have equal to 703W. And now to get the W by itself, we're going to go ahead and divide both sides by 703. We get W is equal to we get 161, say 0.15 pounds. So Keisha's weight is 161.15 pounds. Okay, let's take a look at a different formula, different example. So the number of calories K required each day by a moderately active female who wants to maintain her weight is estimated by the formula K equal to 1015.25 plus 6.74W plus 7.29H minus 7.298. So W is the weight in pounds, H is the height in inches, and A is the age in years. Okay, so let's take a look at the information given to us, and then let's see what we have to solve for. So Serena is a moderately active 25-year-old woman. Okay, so we're given Serena's age, so A is 25, who weighs 150 pounds. So we're also given W, which is 150 pounds. And we're also given her height, so our H, so 5 feet 8 inches, we saw in the previous example, this is 68 inches. Find the number of calories she requires each day in order to maintain her weight. Okay, so let's plug in our information. So we have K equals, and we have 1015.25 plus 6.74 times W. So W is given to us, so let's plug it in, times 150 plus 7.29 times H. Our H is 68. And we have minus 7.29 times A, age, which was 25. Now let's begin simplifying all this. We have 1015.25 plus, okay, now the 6.74 times 150. Okay, that gives us 1011. We have plus, now the 7.29 times 68. We have 495.72. Then we have minus 7.29 times 25, that gives us 182.25. Okay, now let's go ahead and add and subtract these numbers with each other. So you have that 1015.25 plus 1011 plus 495.72 and then minus 182.25. Okay, we get 2,339.72. Now, this is the amount of calories that Keisha needs to eat each day in order to maintain her weight. Now, part B for this question, for this example, it says to solve for A. Okay. Now, this time, we're not given any information. We're not given what K is. We're not given what W is. We're not given what H is or what A is. So let's go ahead and start with the formula that was given to us. We have K is equal to, so it was 1,015.25. And it was plus 6.74 times W. And then we have plus 7.29 times H and minus 7.29 times A. So we're asked to solve this formula for A, meaning we want to get this A completely by itself. Okay, so we want to have the equation as, we want to have the formula as A equal to something. Okay, now that something is not going to be just a numerical value. Our A that we solve for, it's going to be in terms of all these, it's going to be in terms of all these other variables that we have. Okay. So now, just like what we saw in the previous section, if I want to get A by itself, I want to start moving all these other terms to the other side of the equation. Okay, so I want to get this term by itself to begin with. Okay, now in order to get that term by itself, okay, I have to start moving all these other terms to the other side. Okay, so let's take a look at what that would look like. So this 1,015, so this 1,015.25, if I want to move it to the other side, I'm going to have to subtract it from both sides. So I have minus 1,015.25 and minus 1,015.25. This 6.74W, I want to move it to the other side as well. So minus 6.74W. I'm going to subtract that from both sides. The 7.29H, since it's positive, I'm going to have to subtract that to move it to the other side. Okay. Okay, so now let's take a look at what's left over. Okay, so now I have K minus 1,015.25 minus 6.74W minus 7.29H is equal to negative 7.29A. Let me just rewrite this part so it looks a little bit more clear. Now, we're not quite finished solving for A yet. Notice how we have that negative 7.29 in front of it. So this is negative 7.29 times A. So if I want to get A by itself, I'm going to go ahead and divide both sides by negative 7.29. I'm going to divide the whole left-hand side by that same number. And that's going to give us our A completely by itself. So we have A is equal to K minus 1,015.25 minus 6.74W minus 7.29H all over negative 7.29. Let's take a look at another example. So for this one, saying solve for M, and we have F is equal to mv squared divided by R. So now recall from section 1.1 the steps or the strategy for solving an equation. So what we want to do is first look for parentheses, which in this case we don't have any. Then you take a look at fractions. if we do have fractions, we want to multiply by the LCD to get rid of it. So over here, we do have a fraction. So first thing I want to do is eliminate the fraction. So I'm going to multiply by the LCD. Our LCD in this case, since it's just one fraction, it's just that denominator. So we're going to multiply both sides of the equation by r. So we have f times r is equal to mv squared divided by r times r. Now the reason why I'm multiplying by r is now the r in the denominator and this r are going to cancel out. Now I'm left with an equation that does not have a fraction in it. So I have fr, so this is f times r, is equal to mv squared. Okay. Now just keep in mind the goal. We're trying to solve for m. So if I'm trying to solve for m, I want to get that m completely by itself. Now on the on the right hand side, this is saying m times v squared. So I want to get rid of that v squared. Since it's m times v squared, if I want to get rid of that v squared, I could just go ahead and divide by v squared. Now my v squareds cancel out. And now I'm left with m by itself. I have m is equal to fr divided by v squared. Now let's take a look at one a little bit more complicated. In this problem, we want to solve for b. We have a is equal to 1/2 h times a plus b. Okay. So we have a is equal to 1/2 h times a plus b. Remember, our first step with our strategy is to eliminate parentheses. So if I want to eliminate the parentheses here, I'm going to go ahead and use the distributive property. Now what I'm distributing over here is the 1/2 h. So I have capital A is equal to 1/2 h times little a plus 1/2 h times b. Okay. So I eliminated the parentheses. Okay. Now I have fractions in the equation. I can remove those. So LCD in this problem is, so the denominator, so we have two fractions here and the denominators are the same, it's just 2. So our LCD here is 2. So I'm going to multiply each term by 2. So I have 2 times a is equal to 2 times 1/2 HA plus 2 times 1/2 HB. Okay, now simplifying, so the 2 times a gives me 2a equal to, these 2's cancel out. I'm left with HA plus, same thing with this term, these 2's cancel out. I'm left with HB. Okay. So I want to get the B by itself. So I want to get this HB on one side by itself first. So this HA, I'm going to have to move it to the other side. So since this is a positive HA, we're going to go ahead and subtract HA from both sides, and that will get rid of that. So I have 2a minus HA is equal to HB. Now, one last thing to get the B completely by itself, since this is H times B, I'm going to go ahead and divide both sides by H, and that'll give me my B by itself. So I have B is equal to, I have 2a minus HA divided by H. Okay, let's take a look at one more problem. Okay, solve for z. So we have t is equal to 1/6 times x minus y plus z. Okay, so once again, we do have parentheses in this problem. Let me go ahead and rewrite it first. We have t is equal to 1/6 times x minus y plus z. So I'm going to eliminate the parentheses. I'm going to go ahead and distribute this out. You have t is equal to 1/6 x minus 1/6 y plus 1/6 z. Now we have fractions, so let's eliminate that. Our LCD here is 6, so we're going to multiply each term by 6. So you have 6 times t is equal to 6 times 1/6 x minus 6 times 1/6 y plus, and then 6 times 1/6 z. Now let's go ahead and simplify. So 6 times t gives us 16, and we have equal to 6's cancel out over here, 6's cancel out here, and 6's cancel out over here as well. So I'm left with x minus y plus z. Okay. So remember, our goal is to get z completely by itself. So I want to move this positive x to the other side, and I want to move this negative y to the other side as well. So I'm going to go ahead and subtract x from both sides. And I'm going to add y to both sides. So I get 6t minus x plus y is equal to z. And now we have the z completely by itself. So that was it for this section. Make sure if you do have any questions, please email me and I'll get back to you as soon as possible.